Hi there, welcome to TDCatTech. Today I want to talk about torches, or for our American friends, flashlights. They're exactly the same thing. In the UK we use the term torch and it means exactly the same as a flashlight. I think once you reach the age of sort of 40 or maybe just over 40 in my case, it seems to be a sort of rite of passage in a way to have at least a couple of torches around the house. And I've been looking at a few recently, and I'll have a few more videos coming up on some of those torches that I've picked up recently. And they vary in quality a lot, it seems. Torches, you can pick up a torch for like £5, but you can spend up to £500 on a torch if you're buying one that's under the tactical category or, something like that. There are lots of reasons why torch prices can bump up. But effectively, having a rechargeable torch around the house is a really handy thing. The problem we have is that one manufacturer makes claims over another manufacturer to try and make their torch look better. To give you an example of what I'm talking about here, this is the first search that I found on Google, pretty much. I actually typed in 1 billion candle power, but it just kept coming up with million. So I thought, okay, I'll go with 1 million. And this is what it's come up with. It's come up with a new 1 million candle power rechargeable LED spotlight torch 1 million flashlight. This is $14.95. I mean, I'm not saying that it's impossible to have something such amazingly good value that's producing this sort of 1 million candle power. It's got to be really, really amazingly bright, right? Well, this is the problem. You see, candle power is a measurement that's actually largely obsolete now. It's not used at all. So the fact they're using that term at all makes this kind of worthless. But this could be a focused beam, right? This torch could be actually not that producing that much kind of brightness, if you like, not that much power at all, because this could be focused into an absolute minuscule point of light, like a laser, but easily be and be 1 million candle power as a result. Totally useless to anybody, but it could meet that 1 million candle power rating by just massively focusing its beam. I can actually, by the look of this, I think this is just a complete load of crap. So it's probably not even doing that. But you get the idea. Let's just have a quick look at the specs here. Number of LEDs, 1. What else does it say about it? Not really much at all. Okay, let's just zoom in a little bit here. 1 watt, a 1 watt super bright LED bulb. Very good. And that's where the FL1 standard comes in. And that's what I want to talk about today. So before I kind of get into any torch videos and stuff, because I'm completely new to this, there are a lot of people out there with a lot of knowledge on flashlights. They have done a lot of testing and they understand this, through and through. Whereas for me, I've come to this totally new and I'm just sort of researching this. And the FL1 standard is something that I found out about recently because I noticed it was on the side of a lot of the boxes. And yeah, it's an absolutely essential part when you're buying a torch because it means you can make a direct comparison between one flashlight and another. That's the theory anyway. Rather than, for example, a manufacturer saying our torch has an amazingly bright 10 watt LED, well, 10 watts is meaningless because one LED might produce a lot more light using 10 watts of power than another LED. So you can see that just doesn't work. And that's where the FL1 standard came into play, to try and balance things up and give people a fixed sort of, I think it's about 7 points that they can just refer to and say, right, this torch is better than this one because of this. So first one they look at is light output. And light output, they measure it in lumens. And you could say, well, you probably heard the term lux as well, but lux is a little bit different. I'll just explain the difference between the two. So a lumen is actually the level of light from a particular source. Lux looks at actually of illumination of an area. So if you had, for example, 400 lumens of light across a 10 meter squared area, you might have a lux value of 40 or something like that. So they don't use, with torches, they use lumens because who's to say what you're going to be shining it on and how illuminated that area is going to be? So where might you use lux? Well, let's say you had a desk lamp or something like that that's on a fixed stand and is going to sit, I don't know, half a meter above your desk or something like that. It's important to know how illuminated your desk will be with that light on its full brightness. And you may then use the term lux rather than lumens, because how bright the actual light is and the actual source of light is not so relevant there. However, with a torch, we can't make those sort of assumptions. So what they're talking about there is the actual brightness. I don't know if brightness is the right word, actually. How much light is generated by that source, in which case, in most cases, that would be an LED. So you'll see across torches, various sort of levels of lumens, from anything from probably like sort of 50 lumens and up to crazy claims of sort of 9,000 lumens and things like that. And yeah, I mean, I suppose they must be true. I mean, it's incredibly bright and must require a huge amount of power. But you can largely, you can assume that torch, the LED in that torch, will provide more light. What it does with that light is a different matter. And the lumen output rating doesn't factor in that one torch might focus the beam, one might spread the beam, one might be more like just a light bulb or whatever. Doesn't factor that in at all. It's just how much light is coming from that LED. All right, the second one they look at is beam distance. And this again is a difficult one, because they are saying, they're obviously looking like, how far is this beam going to go? So if you shine your torch and you can see it on a tree like 100 meters away, and you're like, wow, God, that's really, really bright. But when they make claims of sort of 250 meters or 300 meters, they're only after an illuminance level of 0.25 lux on that object at the other end. So that's really not much light at all. So if you were 300 meters from something and you were lighting it at that level, you wouldn't be able to see that. I mean, that would be too dark for you to be able to perceive that level of illuminance at that sort of distance. But it is enough to actually sort of see what you're doing. So effectively, I think the comparison is a full moon on a clear night in an open field is the general sort of a comparison that's made according to the documentation that I looked at. I don't know. I mean, I can imagine if I was sat in a field and I had a full moon, and I wouldn't be able to see much detail of what I was doing and wouldn't want to read in it or anything, but I could make my way around. And that's all they're after when they're saying, if they say at 300 meters, how bright's it going to be? That's how bright it's going to be. So not much. The third one is by far the most contentious issue when it comes to the FL1 standard, and that is runtime. So the runtime of a torch or a flashlight is tested from 30 seconds after power on until when the torch is at 10% of the initial brightness. It doesn't give any information about how quickly it goes down, because really this sort of information you have to see graphed. Because you could have a power source in a torch that is able to supply a certain voltage for, let's say you have a runtime of 6 hours. It could supply a certain voltage for 5 hours and then drop off really quickly, in which case you've got a torch that's amazingly bright for 5 hours, but then starts to drop off. Alternatively, you could have a really rubbish battery that drops off after 10 minutes, and effectively your lumen level of your LED is down from maybe 900 down to 50 after 10 minutes. And then it just sort of tapers along at the bottom. And it's a kind of just a fairly dull torch then for the rest of the time, for 5 hours and 50 minutes. That's not factored in. They'll both still have a runtime of 6 hours, according to the FL1 standard. It is massively missing. It's effectively useless, because while it does give you information of how long the battery will last, it gives you no information around how useful the torch will be to you for that period of time. Okay, the next one we've got is peak beam intensity. Now, this is the one that you need to look at to effectively say, is this torch a spot or is it a wide wide beam torch, because if it's a spot, if it's focusing its light into one sort of bright little spot, which obviously they can then potentially reach further, you would think, it's going to have a high candela rate value in this peak beam intensity, and that's kind of all it's used for, really. It is because you're missing that in the lumen section. This will give you that information, because if you've got a torch and it's a wide, it doesn't have any kind of focusing kind of elements or anything like that in the top. It could light a room really well, or feel like it's lighting a room well, but it would have an extremely low level on this particular rating. But that doesn't matter, because that might be what you want from that torch. However, you might have a fairly low, fairly sort of small little torch, maybe just a pocket-sized, tiny little pocket, or maybe even a keyring torch or something like that. They might have a really high peak beam intensity just using a really tiny battery. The fifth one is impact resistance, and this is just a case of drop testing. And drop testing to me is a bit of a dark art, really, because you can drop something and you can drop it in testing, and you can drop it once by yourself and it can do totally different damage. It's nice to do, and obviously it proves the fact that it can probably stand a couple of drops, but in real life, you just might catch it on that awkward spot, and it means that the drop testing then becomes completely irrelevant. So I'll just read this word for word that it says on this particular sheet that I'm looking at. This testing is completed by dropping the product 6 times using drop orientations that approximate each side of a cube. Dropped samples cannot have any visible cracks or breaks and must remain fully functional. The next two are obviously some of the key ones to people, and that's water resistance and waterproof rating. So water resistance is looking at products that are anything less than IPX7, anything less than that, so IPX5, for example, or IPX4. And notice that I use the term IPX. That's because the FL1 standard doesn't test for dust at all. You'll see them all quoted as X something, and that means they are missing off the dust ingress testing. It doesn't mean that the product is going to let in a load of dust. It just means that this particular standard is not interested in looking for that. It's not trying to test for that. So the first one, or the 6th rating on the FL1 standard, is water resistance. So you might see something that is IPX5 or X5 would be testing, it's suitable for kind of rain and jets and things like that, but you can't actually put it in water. You can't submerge it in water for any period of time. So a lot of people will always look for IPX7 or IPX8. I think there might even be a 9 actually, which is the final part of this rating, and that's waterproofness. Is it waterproof? And it means you can actually put this thing in water at 1 meter for 30 minutes or at least 30 minutes. And then you've got IPX8, which is even more than that and even deeper than that. If you drop it in something, if you drop it in water, if you use it underwater, effectively, IPX7 is going to be okay. IPX8 for depths is going to be even better. And that's, I think, what people will look for in any kind of torch. They will want something that has decent runtime. They'll want something that has a decent lumen level, and they'll want something that's waterproof. So there we go. That's the FL1 standard. And I've seen this standard quoted and written on boxes, and obviously there's no evidence that the actual manufacturer has tested for this, but I would like to think that if they're putting it on the side of their boxes, the product has been tested for this. But as far as the actual standard goes, that runtime is absolutely useless. It totally needs to be changed. It needs to be, something that says it maintains peak brightness or within 20% of peak brightness for a period of time, rather than just this random, how long it takes to get down to 10%. Totally useless. So anyway, there we go. Just a bit of a chat about the FL1 standard and why you see this on all torches and flashlights. And hopefully that information, if I've got anything wrong, by the way, please do correct me in the comments. As I mentioned at the start of the video, I'm totally new to this. This is not something, not my area of expertise. I'm just quoting this from my research and looking into it for to educate myself, and so I'm able to talk more sort of informatively about flashlights in future videos. So I hope you found this interesting, and I hope it was helpful to you. You can read all this stuff online. You know, this sort of stuff's available easily online. But hopefully having me talk through it there has helped. If you've got any questions, do put them in the comments. If you've got anything to say that I got wrong, please put it in the comments. And if you liked the video, please do consider subscribing. Thanks for watching.